So now we're going to do the same thing for graphing secant. You don't have to fill in this chart if you don't want to. We are going to go back to this GeoGebra website. So I'm going to clear this out, and now I'm going to press cosine because secant is the reciprocal of cosine. So the cosine function is this green one, and one cycle looks like that, down and then up. And then secant, so how is secant related? That is this blue function. So you can see it's kind of like two half curves, one full curve. So we have a little piece, and then a full curve. So this is because one cycle of the secant function is cut off in a weird way. We have at pi over 2 and 3 pi over 2, they're asymptotes. So pi over 2, 3 pi over 2. So all of the like pi and a halves will have a asymptote. And if we were to continue this on, there would be another side to these little loops. But like I said, where we have one period, it's cut off. So once again, when there's a maximum for the cosine function, there's a minimum for secant, and same thing here, minimum for cosine, maximum for secant. So let's look how this looks on Desmos. So if I graph the secant of x, it looks very similar to cosecant, and it goes on forever. So this is what, I zoom in here, this is what we were looking at on that sheet. So from 0 to 2 pi, we have a little half curve, a half curve, and a full curve. But if I expand this, you'll see that these half curves actually do create full curves. But where we cut off 2 pi, it just happens to be at a weird place in the curve. All right, so going back to here, if we were to graph this, draw this on here, we would have asymptote, asymptote, and on the y-axis you have a half curve up, on the other edge you have a half curve up, and in the middle you have a full curve down. And like I said, if we were to draw more than just one cycle, you would go on and connect that and then make another asymptote, and then it would go down, asymptote, and then it would go up. But the red, what I have drawn in red here, is just one cycle for this function. So what do you notice about secant compared to cosine? Same as sine and cosecant. The differences are that they are not continuous. There's asymptotes. It's a completely different shape. It's little curves rather than a flowing wave. And how they're related is that the maximum of the secant function is the minimum of the cosine and vice versa. So now looking at this, what is the period of secant? It is 2 pi. The asymptotes are at all of the pi and a half intervals. So we could say multiples of pi over 2. And the range as well goes from -1 to 1. So you can see that on the graph. It's like nothing in the middle here except for the asymptotes, which are invisible lines. They don't count. So from -1 to 1, you're not going to have anything here. Local minimum. So the minimum, bottom of the curve, we have one at 0, 1, and we also have one at 2 pi 1. So 0, 1, and 2 pi 1. And our local max, which comes from the top of a mountain here, is at pi -1. And that is your secant function.